fine-tuning. Yes, so first I will talk about supervised fine-tuning, and uh, I will briefly introduce why we need supervised fine-tuning. Why do we need to fine-tune such large language models if there exists an already instruction fine-tune of such models? And then I will talk about the instruction following datasets and the dataset that I have selected to actually work with through this workshop. After that, I will briefly introduce quantization, LoRa, QLoRa, and then I will introduce two more techniques that will help us to finally fine-tune a big model with, for example, 7 billion parameters on a single GPU that Google Colab provide for us. One note that I should mention is that since the general audience of this workshop is an open general audience, I mean, not everyone is an expert in this field. I will try to introduce all these topics from the beginning, and I will introduce them uh, from scratch, and I will try to actually explain the concepts rather than explaining the details about each of these techniques or methods that are presented. So if you think that some of them are already actually uh, known to you, it might be a bit boring for you, but at the end, we will actually work out through the fine tuning, and it might be instructive for you. Okay, so first let's talk about supervised fine tuning. You might already be familiar with supervised and unsupervised learning algorithms in traditional machine learning. As you know, supervised learning algorithms are those algorithms sorry, that are dealing with label data. So, sorry. And as you can see in this figure, in the right part of the figure, we have different points in our actually 2D space, and some of them are blue, some of them are orange, and some of them are gray. And that means some of them are related to class 1. For example, the blue points are related to class 1, some of them are related to class 2, and the gray ones are unknown classes. In such a scenario, when we want to train a machine learning model or machine learning algorithm, we already know about the output of each point or record in our dataset. But in an unsupervised learning algorithm, as you can see on the left side of this figure, all the points are all from an unknown category, which we don't have any information about their label. And the outcome and actually the goal of unsupervised learning is different from supervised learning. In supervised learning, we are trying to somehow predict the label of a test data of that sample. But in an unsupervised learning algorithm, we actually are more concerned about clustering these unknown data and records in our data set. So as an example, we can say, for example, a text classification in which we have label for each record in our dataset could be a supervised learning. A text summarization also, when we have a summary for our documents in the dataset, could also be a supervised learning task. On the other hand, for unsupervised learning algorithms, we could mention K-means clustering, principal component analysis, and such algorithms that are actually working with unlabeled data. So why do we need to actually apply supervised fine-tuning on pre-trained large language models? The thing is that these large language models are pre-trained on a massive corpus of unlabeled text data using next token prediction or autoregressive objective function. And as you can see in this figure, on the right side of this figure, sorry, on this on the right side of the slide, when we provide the model with a sequence of tokens, the model is supposed to predict the next token of the provided sequence. So if we say we have the robots and we provide the model with these two tokens, the model will generate the next token of actually this sequence based on the vocabulary of based on its vocabulary. For example, it will provide a probability for each of the tokens in its vocabulary, and it usually selects the highest probable token as the next token of the given sequence. And then in the next step, it will append the actually predicted token to the input sequence, and it is again supposed to predict the next token. And this actually iterative process happens until the model predicts an end token, which means that the sentence is completed and the generated output is completed for the model. In that case, the generation stops. So this is the pre-training actually objective of these large language models, and these models are pre-trained using such technique. But there are such issues that we cannot use such models that have pre-trained using such objective as is, and we need to actually do some post-training or fine-tuning process to actually adapt them for our downstream task. Some issues could be actually when they are trained on such objective, they are not able to answer the question of the user properly. And they might also generate repetitive text. They just append the next token to the previous tokens, and it's not always guaranteed that the answer to the question of the user is provided in the generated token. And one of the reasons for that is that in the data sets that in the actually data that are used for peer training such large language models, they are trained on all the data from internet, and in most of the data that they are trained on, they don't have question and answer pairs. So that's why they cannot inherently answer to the questions after pre-training phase. The technique that is used to align such models for answering to the user questions is called instruction fine-tuning. And using instruction fine-tuning, they will be able to answer to the questions of the user, and they can behave like a chatbot, let's say. So you might say that, okay, all these big companies like Meta, Google, and Microsoft, when they publish a pre-trained large language model, they also provide the instruction version of these models, which means they also have instruction tune those models on an instruction following dataset, and they have also provided that model for us. So why do we need to again instruction tune these pre-trained large language models? That point is true, but the thing is that if we want to adapt these models for a specific task, for a specific domains like medicine, like finance, like law, we still need to supervise, fine-tune these models on a downstream task and with specialized data that we have for that domain. So again, the technique of supervised fine-tuning will be required for actually adopting such pre-trained large language model for downstream tasks and specialized domains. And as you can see in this picture, there are different applications of large language models like content creation, customer support, code generation, that in which all of them, the pre-trained large language models have to be fine-tuned on a specific specialized domain. But there is an issue with fine-tuning of such large language models because they have actually billions of parameters, and it's very resource consuming to fine-tune such models. It requires massive GPU resources. Let's have an example. For example, if we want to fine-tune a 7 billion model, and let's assume that for each parameter, we can actually store the weight values of these parameters as a 32-bit float variable, or FP32. A 32-bit could be actually simplified to 4 bytes. So having a 7 billion parameter model, and for each parameter, let's say we have 4 bytes, we end up requiring 28 GB only for loading and storing the model parameters in the GPU. So this is only for loading and storing the model, not even fine-tuning the model. If we want to do the full fine-tuning of the model, we require at least 4 times of this 28 GB, which is around 112 GB of GPU memory. Uh, this is pretty huge, and that's actually not something that we can actually have in academia. In academia, we usually have GPUs that has at most 32 or 40 gigabytes of memory. So with the techniques like quantization and parameter efficient fine-tuning methods, we can fine-tune such models that will require only one single GPU, having around 16 GB of memory. I will go through them in the next slide, and we will see that how we can compress these models and also use techniques to efficiently fine-tune them only on one single GPU. But before that, let's see the dataset that we are using in this workshop and in this part of the workshop, actually. As I said before, the LLMs were pre-trained using the next token prediction objective, and the pre-trained version of these models is not able to necessarily answer to the questions of the user. And as I said, we need to instruction tune these models to actually make them answer to the questions properly. As you can see in this figure, I have asked a pre-trained Llama 7 billion model a simple question that which city is the capital of Canada, and the generated answer by the model is something repetitive. And even though Ottawa is provided in some part of the answer, it's not something human readable. It's not something well aligned that we can use it in a regular and a daily base use case. So as you can see, for example, Ottawa is provided, but after that, the sentence is not finished. It is also an unfinished sentence here. But if you ask the same question from a instruction tuned model, we can see that the answer to the query is properly provided. The answer is the capital of Canada is Ottawa, and although the model could generate more tokens after that, it has ended its generation because it has put an n token here at the end of the generation. That's the ability that the supervised fine-tuning and instruction tuning of these large language models gives us to create a chatbot, actually. So for this workshop, I selected the alpaca dataset, which is I guess, one of the first open source instruction following datasets. And it was actually released by a group of researchers from Stanford University. It contains around 52K instruction following records, and it was generated using the TextAvinci O3 engine from OpenAI, I guess. And as you can see, one single record in this dataset has 4 fields. One of them is instruction, one of them is input, the other one is output, and the text is output is actually the prompt, which is the combined version of all these 3 fields. So in an instruction following data set, we have an instruction which we will actually ask the model to do a specific task for us, to answer a specific question for us. If that task requires some inputs, we also provide those inputs in the input field. And in the output, we have to provide the answer to the task or question that we have asked from the model. Some of the inputs, the records in our dataset might not require to have an input. And we will see later that we don't need to put such input in the dataset in the actually training phase in the training script that we'll see later. So this is an example of a record in this data set. And if we want to provide the model which a prompt that it will be able to actually learn instruction and also be able to answer to the question of the user, we have to actually format the input prompt similar to something that we can see here. We need to actually provide a description of the task that the model is required to answer. We need to specify a specific instruction that the model is required to actually do. And then if it requires input, we need to provide the input. And finally, it requires to provide the response. Is there any questions so far? So is everything okay? All good. Okay, so this is as I said, one of the records and the way that we have to format the prompt that we will actually feed to the model to actually perform the fine-tuning process. After that, I want to talk about a little bit the quantization. As I said, when we want to actually download and load a 7 billion parameter model, if we, for example, store each parameter in a 32-bit floating point variable, we end up requiring 28 GB of parameter. But there are also other representations for these weight values of these models, like floating point 16 and floating point 8, which require less bits for actually storing each parameter of the model. They are actually low precision data types. And although we lose some information about the knowledge of the model will lose some information, its accuracy might drop, but that drop in the accuracy of the model is not a lot. And if we, for example, quantize these models using such techniques to actually represent their parameter using low precision data types, we will end up having almost a similar model with the same ability, but with a more efficient actually technique to store them in the GPU. The thing is that we can compress these models by, for example, using floating point 16 or 8 instead of floating point 32. But again, fine-tuning these models using these data types is challenging. And some papers that I will mention later have introduced techniques to actually enable these models to perform fine-tuning on even low precision data types. So basically, by quantizing these models, we are able to store these models on GPU, on a single GPU. But if we want to do fine-tuning using these low precision data types, we still have to deal with some challenges. Okay, so the technique that we are going to actually use in this workshop is LoRa or low rank adaptation. The idea behind this technique is very simple. And as you can see here, if we have, for example, a weight matrix W, which has dimension of D times D, and it's, let's say, a pre-trained weight of a large language model for example, a specific layer, we can actually somehow ignore fine-tuning this weight matrix, this pre-trained weight matrix during fine-tuning phase. And instead, we can fine-tune two decomposed matrices that were actually obtained using this pre-trained weight matrix. For example, if we have a weight matrix of W with dimension D times D, we can drive two decomposed matrices A and B, and A could have a dimension of D times R, and B could have a dimension of R times D. And this R is called rank, which is actually, I guess, clear for everyone. If we, for example, multiply A by B, we can actually have a matrix with the same dimension as the pre-trained weight matrix W. So why do we need to do that? The thing is, if we wanted to fine-tune the model using the pre-trained weight matrix W, we had to fine-tune D times D parameters per each layer, per each linear layer, actually. But if we decompose the weight matrices in such a way, we only require to fine-tune A and B matrices. And these matrices, if we select a low rank for them, let's say a rank of 2 or 4 or even 8, could be very smaller compared to the pre-trained weight matrices of the model. And as you can see here, the way that these matrices are injected into the model layers, again, is very simple. For each layer, we have to actually replace the pre-trained weight values with actually the pre-trained weight values and also these decomposed matrices. So if we, for example, have a vector of dimension D, which is the output of the previous layer in our large language model, we should actually fit this output to both of these two matrices, the pre-trained weight matrices and also the decomposed matrices. The forward propagation will happen and the output will actually be computed for each of these two matrices. And finally, they will be actually summed, and the result would be passed to the next layer of the model. This is how LoRa actually tries to lowers the amount of the parameters that are required to fine-tune a large language model. And the benefits are actually it reduces the memory footprint, and a good thing is that it maintains the model performance. Although we reduce the number of the parameters that are required to fine-tune a large language model, and it would be proportionally very low compared to the whole parameters of the model. The performance of the model is somehow actually comparable to the performance of the model when it is fully fine-tuned. And by fully fine-tuned, I mean the entire parameters of the model are fine-tuned, right? So again, these are two benefits of LoRa. The first one is that it reduces the memory, the required memory for fine-tuning, and the second one is that it actually maintains the performance of the model. But what about QLoRa? QLoRa actually uses three more innovations to actually even reduce the memory that is required for fine-tuning of these large language models. So LoRa only actually uses these low rank matrices, and it doesn't do anything about quantization. But in QLoRa, the authors of the paper were actually able to fine-tune a quantized version of the model all actually, in addition to have this low rank and decomposed version of the models. So the innovations that they have actually introduced is that they introduce 4-bit normal float actually data types for quantizing the weight parameters of large language models. They also introduced double quantization and page optimizers. I don't go to them deeply. They are actually the techniques that we don't necessarily need to implement them ourselves. We will use libraries that have implemented such techniques, and we can just call their API, and we can easily use these techniques to fine-tune these models. So as I said, as a recap, QLoRa is actually, let's say, next generation of LoRa that uses both LoRa and quantization to reduce the required memory for fine-tuning such large language models even more. There are also other PEF methods. As you can see in this figure, there are different PEF methods that each of them target different layers in the actually transformer block of the large language models. As you know, all of these models, large language models, actually most of them are based on the transformer architecture, and they are decoder only based models that have the decoder block of the transformer architecture. And there are different parameter efficient fine-tuning methods that target different layers of these models, and they try to freeze the rest parameters of the model and only fine-tune a small portion of these actually parameters in order to reduce the required memory during fine-tuning phase, while actually maintaining the performance and having a comparable performance compared to the full fine-tuning of the model. As you can see in this figure, there are techniques like bitfit, Halsby, which was, I guess, one of the first techniques that was introduced in the domain of parameter efficient fine-tuning metric techniques, sorry, and prefix tuning, other techniques that exist. And there are lots of even works that are currently being done as the next generation of LoRa. And there are many techniques that are only based on LoRa. Okay, so far we could be able to use LoRa and QLoRa to actually reduce the required memory for fine-tuning a large language model. But even if we apply these techniques, we are still going to encounter out of memory error. And we still need to apply more techniques to lower the amount of the memory that we require for fine-tuning such models. Another technique is called gradient accumulation. And this technique is actually related to the batch sizes. As you know, and already familiar with the batch in the machine learning and deep learning process, when we want to train a model, when we are dealing with large amount of data, we don't feed the model the entire training data set at a time. In fact, we split our data set into different mini batches and feed the model each batch at a time. And in that case, we could actually save the memory that is required for doing the training process if we have a large data set. That is okay, but the thing is that with these large language models, even selecting a batch size of 8, 16, or even lower, let's say 2 or 4, is hard. If we, for example, have a batch size of 2, we might still run into a actually out of memory error. To overcome this issue, the technique that people use is that they actually set the batch size as 1, and they set the gradient accumulation step as something like 4 or 8. And the way that it works is that for each batch, we need to actually compute a gradient, let's say gradient 1, and for batch 2, let's say gradient 2, and for batch 3, gradient 3. For previously, when we wanted to actually compute the gradient, we uh, did it for each batch, and after computing the gradient, we updated the model weights directly after computing the gradient for each batch. So that worked, but it was okay at that time. But right now, since we are using batch size of 1 for these large language models, we want to have, for example, a batch size of 8, let's say. In that case, we need to, for example, put the batch size as 1 and put the gradient accumulation steps as, for example, 8. In this scenario, after actually computing the gradient for each batch, the gradient updating will not happen directly. Instead, these gradients will be stored, and then after the gradient accumulation step size, which would be, for example, something like 4 or 8, the gradients are accumulated, and then the model weights are updated. This way, we can somehow overcome the issue of having a low batch size, and then we can also overcome the memory that the amount of memory that was required for having a large batch size, right? This is another technique that we will use, and there is also another technique that is called gradient checkpointing. In this technique, it is related to actually activations from the actually each layer of the model. In a traditional actually deep learning network, deep learning neural network, when we were doing a forward pass, when we were actually computing the actually output of the model based on an input, we require to compute the computations and then cache the actually activations in order to compute the gradients in the backward propagation algorithm. That required a lot of actually memory, because we needed to, for example, compute and cache the activations of a model which has, for example, 32 layers, and we needed to cache all of the activations for the backward propagation algorithm. But that requires a lot of memory. But if we want to overcome this issue, the thing that we could do is that we could forget the activations and recompute them during the backward propagation again. This way, we don't need to cache those activations during the forward pass, and we could easily reduce the amount of the memory significantly. But there is a issue with this approach, and that's the number of the computations. Previously, when we cached the activations, we could use them in the backward propagation, but right now, when we are actually not caching them and we are recomputing them in the backward algorithm, we require lots of computation, and this will add up to the training time for the fine-tuning process. This is a downside of this technique, but it will reduce the required memory very significantly, that we can easily actually fine-tune a large model on a single GPU. And all of these techniques actually combined with each other will actually lead us to fine-tune a large language model on a single GPU. If we, for example, do only one of them, we might still encounter a out of memory error. So for such large language models, let's say a 7 billion model, a 13 billion model, we need to actually apply all of these methods together to be able to reduce the memory to finally fine-tune the model on a single GPU. So that's it so far. This is the end of the techniques that I wanted to mention. And is there any question? Because in the next step, we want to go to the code and we want to see actually how we can fine-tune the model. All good. So I assume you have already access to the script for fine-tuning the model. So I will bring up the script. And from now on, you can also follow the script to see how we can continue and fine-tune a large language model. And I will explain everything on the code. So after actually opening a Google Colab environment, we need to connect to a GPU environment. If you open this actually bar here, you need to go to resources. And if you want to select, let's say, okay, if you want to change your runtime, you can see that there's a button here. If you are already connected using a CPU, you can change your runtime and you can change it to T for GPU here. And this way you can be able to access to the GPU. And in that GPU, you have access to 15 GB of GPU RAM, which is enough for fine-tuning a 7 billion model. First of all, we need to install some of the libraries that we require. Hopefully, the techniques that I explained, some of them are very challenging, and actually all of them are very challenging to implement. And there were groups of people that have introduced and implemented those techniques. And hopefully, with these libraries, we don't have to deal with the implementation of those techniques. We can just call the APIs and only set the parameters, hyperparameters, to apply those techniques and be able to fine-tune the models. The libraries that we need are datasets for loading the dataset, TRL for supervised fine-tuning, PEF for actually calling the LoRa configs, bits and bytes, and accelerate for actually quantizing the model that we will see later. So first, we need to install these libraries. It will take a few minutes, but it will finish soon, I guess. So you can also run it simultaneously. There are also some libraries that we need, for example, transformers, but these libraries are already installed in Google Colab environment, so we don't have to install them again. Only those that aren't installed already are required to be installed. I'm not sure, maybe PEFT is already installed, but it's better to install all of them so we don't have to uh, install them again. Okay, so the libraries are installed, and then we need to import the required classes and functions. From the dataset, we need to import the load dataset function, which will be used to load the dataset from Hugging Face. From TRL, we need to import SFD trainer and SFD config. These two classes are used to fine-tune the model. SFD config is used to actually set the hyperparameters, and SFD trainer is the class that is used to fine-tune, that is used to apply the training loop and all that is actually the training process of the model. From PEF, we need to import LoRa config, which we need to set the layers that are required to apply LoRa on them, and also the rank of the LoRa. And from transformers, we need to load auto model for causal LM, and bits and bytes config and set seed. We set the seed to actually be able to produce same outputs for different run. Okay, so after importing the required classes, there is a function which is print trainable parameter, which prints the number of the trainable parameters. And if you remember, when we are using a parameter efficient fine-tuning technique, we are actually freezing a portion of the parameters of the model and only fine-tune a subset of the parameters of the model. Using this function, we are able to print out the trainable parameters of the model, and we will use it later, but there is a point about that I will mention it later. Here, the main thing somehow happens. We need to actually specify the hyperparameters that are used to fine-tune the model. We use the LoRa rank of 8. Different ranks could be used. The higher the rank that we use, the higher GPU and the more GPU we require. So it's better to keep it around 4 or 8. If you have bigger GPUs, you can use lower ranks of 16, 32, or even higher. The dataset, as I said, it's the alpaca dataset, and the model is Llama 7 billion Hugging Face version. The input field of the dataset is input, the output field is output, and the instruction field is instruction. These are for the simplifying the code that we will use later. We won't be able to actually fine-tune the model in this workshop, but we will show you that we can start the fine-tuning phase without encountering the out-of-memory error. So for now, we have set the epoch as 1, the number of epochs, and we have set the training micro batch size as 1. If you remember, I said about the gradient accumulation in the last slide. So we set the training batch size as 1, and then we set, for example, gradient accumulation step as 4. In such a scenario, we will have a batch size of 4. It's something like having a batch size of 4 that we were using previously. Okay, and we are not doing evaluation in this example. I have set it here as 1, but I won't use evaluation. I want to just show you how we can use training on a actually data set. The default value for learning rate, the learning rate scheduler type would be linear. These are other hyperparameters that you might already be familiar with if you have tried fine-tuning or training smaller models. And the login strategy is steps, meaning that in each step we will log the training loss, and the actually logging step would be 1, meaning in each step it would be logged. The optimizer is Adam W 8-bit, which is a low precision version of the Adam W that is required for having actually to actually do the optimization. It happens under the hood, so we don't have to deal with that. We just need to set the optimizer. And the good thing is that it's an 8-bit optimizer. So again, similar to quantization, it reduces the amount of required memory. And the maximum sequence length for the generation of the model would be 512. And the maximum steps that we have set to apply the actually fine-tuning and training process is 1000. You can put this number based on the number of records in your data set. But again, in this session, we are not able to complete the fine-tuning process. We are only to starting and showing you how we can do that without running into a out-of-memory error. Here I have actually set the seed to be able to reproduce the generations again. And after that, we need to actually set the configuration for QLoRa and LoRa. For the QLoRa, we need to call the bits and bytes config and set the parameters of loading for bit true. As if you remember, I said that the data type that is used for loading the parameters for in the QLoRa paper was normal float of 4, which is a 4-bit version of the parameters. And we should also set the value of use double quant as true to actually apply all the techniques that were introduced in the QLoRa paper. After that, we need to actually set the configuration for the LoRa and specifically for the layers of the model that we want to inject LoRa actually layers. We also need to set the rank of the LoRa layers, which I had selected as 8 here. And in target module, we can select the layers of the model that we are going to apply LoRa on them. Since we are using a Llama 7 billion model, all these layers are linear layers that are actually used in each decoder of the model. So we can apply LoRa layers on all of these actually layers, and the model will be loaded in actually linear 4-bit format for all these layers. And the task type that the model is actually supposed to perform is causal LM, which is the actually primary language modeling task that these large language modeling are doing based on the next token prediction objective. So by setting this, we can, after that, load the data set. All we need to do is to call the load dataset function and pass the name of the dataset to it. The dataset will be downloaded from Hugging Face. It's a pretty small dataset with 52K records. And as you can see, I have printed one sample of the record and it doesn't have any input. So the input field is empty. The output that the model is supposed to provide is here, the instruction, and also the text, which is the actually format of the prompt that we have to feed to the model. After loading the dataset, we need to load the model. Again, it can be done using the auto model for causal LM, which is a class of the Hugging Face Transformers library. And by using the from pre-trained function of that class, we can pass the name of the model and also pass the quantization configuration, which was the Q-LoRa configuration to the model. And by putting the device map as auto, we can the actually model will be automatically loaded in either CPU or GPU. If we have GPU, it will be loaded on GPU. And if we don't have access to GPU, it will be loaded on CPU. If I run this cell, this will take quite a few minutes, and you can also run this cell to load the model. Since this is a 7 billion model, it requires to download around 28 GB of data. And as you can see, the model itself is partitioned into different parts. So it has around 33 shards, and all of them are required to be downloaded and then loaded into the GPU using the BNB config that we provided previously. So you can also run this cell to download the model, and then after that we can run the fine-tuning process. Is there any questions so far? Okay, sorry. So I didn't check the chat. Hopefully, yes. Hopefully you have provided with the script in the chat. So I hope that everything is okay. So yeah, well, we need to wait until all the shards of the model are downloaded, and then we can continue the fine-tuning process. Okay, so while the model is downloading, I can actually explain the architecture of the model a little bit. After the model is downloaded and loaded, you can print the model to see the architecture of the model. As you remember, it's a transformer-based model, so it has, but it only has the decoder part of the model. It's only a decoder-only model. And it's a Llama model. As you can see, it has embedding tokens. It has an embedding layer with the size of 32,000 times 4,000. And this 32,000 means that the number of the vocabulary in the model is 32,000. So this model can generate 32K distinct vocabularies. And for each of these tokens in the embedding of the model, the embedding of the token actually is 4096. So each token in the model is represented using a vector of size 4096. After the embedding layer, we have the Llama decoder layers. And in the decoder layer, we have attention layers. In the attention layer, we have query, key, value, and output layers. Since this model is loaded in 4-bit quantization, actually precision, all these attention layers are in linear 4-bit format. But if we were printing the model that was loaded, for example, in a full precision format, it would be a simple linear layer without any 4-bit actually precision. And after the attention layers, we have the MLP, the multi-layer perceptron layers that again, they have gate project, up project, down project layers. They are still linear layers. And if you remember up here, we applied LoRa matrices to these layers, to all these linear layers. So when we are fine-tuning the models, those LoRa layers will be applied to all these K-proj, K-proj, V, and O-proj, and also the MLP linear layers. And these linear layers, the LoRa layers that were applied to these linear layers will be fine-tuned, and the rest of the layers of the model, for example, these RMS norm layers, the embedding layers, and even the language model head layer will be frozen during the fine-tuning phase, and only those LoRa layers will be updated. Okay, so I guess the model is downloaded and we can now use it. If I print the architecture of the model, you can again see that the same architecture exists. Before starting the fine-tuning, we need to format the instructions or the prompts to the model. To format the prompts, we need to actually follow the prompt format that I presented in the slides. We have to provide the actually an instruction and a description for the model. And after that, we have to provide the instruction by writing a function that takes an example of the data set. We can take the instruction, input, output of each example, and actually put them in the format that we want to fit the model. And if you remember, we said that if the input field of the data set is none, we don't need to provide it. But if it's not empty, there is some input for the record, we have to put it here in addition to the instruction. And finally, we have to also provide the response. So the model is supposed to generate such response for each instruction and input. Okay, so after formatting the prompt, we have to actually pass those hyperparameters that we said previously. Let me show you these hyperparameters. We need to pass them here to the SFD config, which is a class of TRL library. And we need to pass all those hyperparameters to this SFD config to actually define the hyperparameters. And finally, what we can do is actually define the SFD trainer, which is a class for training these models. And all we need to do is to pass the model to this SFD trainer, the data set, the trainer split of the data set, and also the arguments that we have defined here, and also the LoRa config and the formatting function that we have defined here for formatting the prompts to the model. In a regular case, if we didn't actually do any of these quantization, parameter efficient fine-tuning, and all the other techniques to actually reduce the required amount of the memory, we wouldn't be able to start the training process, and we could easily encounter a out of memory error after running this code snippet. But right now that we have provided all of these techniques and methods, we will be able to start the fine-tuning phase, and hopefully we can see that the model will be able to calculate the loss for each batch of the data set. And as you can see here, the GPU that is used currently is very low. Even it's not even used all of the GPU that is provided by Google Colab. We have 15 GB of GPU, but around 5 GB of the GPU is used. Okay, so let's see if the model is able to start the fine-tuning phase. It's trying to tokenize the training data set. I didn't mention the tokenization part. It will be done using the SFD trainer itself. But if we want to customize it, if we want to do a tokenization for our data set or our model that we have provided, we can set those tokenization separately and tokenize the data set separately and then pass them to the SFD trainer. Right now, I just selected the default tokenization. So it will use the default tokenization for the Llama model. So as you can see, the training process is starting and the model is calculating the loss function for each step of the training process. Again, as you can see, the GPU that is used is significantly lower than the amount of GPU that we are needed to have when we are fully fine-tuning such model. Only loading such model that had 7 billion parameters requires 28 GB of GPU, but we are now fine-tuning such a model by having only 15 GB of GPU. As you can see, the training loss has calculated for step 1. It's again being calculated for other steps. And this training loss should be actually reducing in the future steps. So I guess that's it for the presentation. So, and I hope that you were also be able to run the script, follow the steps, and be able to actually start the fine-tuning phase. As you can see, the loss is also reducing. And a downside of this actually approach is that it will require lots of actually computations, and the computation time will be higher than a normal fine-tuning process. So although it reduces the required amount of GPU for fine-tuning such model, it adds up to the computation, and it may take a bit higher to fine-tune such models, and especially if the number of the parameters gets even higher. Okay, so this training will be actually done. Unfortunately, Google Colab has time limits, so we cannot continue the fine-tuning process until the training process is being finished. But in Digital Resource Alliance of Canada, that we have access to GPU clusters, we can do the same process with only one single GPU and apply the fine-tuning process. So I will stop this actually fine-tuning process, and it will require a lot of time to finish because the size of the model is too large. Okay, so is there any questions so far? So which module do you mean? If you could mention which module.
I think someone asked if it's possible to get the module too. So I I just want a clarification. If the
Mhm.
person is talking about a pre-trained model, or if we could get a clarification, please.
Uh, so I didn't get which module they meant. But yes,
Yeah,
we can.
because
Yeah.
I can't seem to see any clarification. Maybe if we could get clarifications. Somebody else is asking another
Mhm.
question. Could we save all files? Could we save all files to any folder?
Uh, if you mean the model or the data set, yes, you can save it in your environment here in your Google Drive and then load it from your environment Google Drive. Uh, I used the standard data sets that were already presented in Hugging Face, so uh, they were downloaded from Hugging Face.
Okay.
But you can,
I think
yeah.
she's talking about the pre-trained model. Um,
Same as the pre-trained model. You can also download the pre-trained model from Hugging Face and then put it in your Google Drive and then access it using the same method. You don't need even to change the method. If I bring up the loading part here, you just need to pass the path of the model to this function. If it's already existing on the Hugging Face, it will download. If it's already existing in your environment path, uh, it will actually load it from your environment. But if it's not existed in your environment, it will try to download it from Hugging Face. So uh, if you remember, we passed this model name as the name of the model. You can separately download this model from Hugging Face, same for the data set, and put them in your Google Drive and then pass the directory of those models and data set to this loading functions.
okay, so there's another question. Someone is asking, how do we source this data? I think the Stanford Alpaca data set. I think that's what they mean.
Yes, so this data set, the Alpaca, if you mean how we can get the data set, you can go to the Hugging Face website. I will. Hugging Face is actually an ecosystem that provides pre-trained model data set for different fields and actually tasks and domains. Here, if you search for Alpaca, you can let me copy and paste this name. You should also put the provider name. So if you come here into the dataset section, you can see that the dataset exists here. You can go to the, sorry, Files and Versions tab. Under this tab, you can download the data here. And this is one way you can access the data set. The other way that I mentioned is just calling it from the loading data set by passing the name of the data set, and it will automatically download it from the Hugging Face space.
If there are any other questions, please you could leave them in the chat. We are still gonna also provide the ways to actually reach out to the facilitators. If outside of the workshop you try to fine tune on your own on maybe a different model, which will actually encourage. If you try to fine tune a different model using a different data set and you run into errors, so you can actually access or talk to anyone so they could help you out. I've also attached, I'm going to attach a link here to the Google Drive that contains the PowerPoint presentations, the scripts, and files um, for this workshop, for the entirety of the workshop. So you can just see everything that the workshop contains. And if you're doing projects that relate to large language models or data and you find it a little bit difficult, we have like a DRI ask space where you could ask questions or have help with your projects. Thank you.
Okay, thank you everyone. That was the first part of the workshop, and I hope it was an instructive actually presentation for you. You can use it in your later projects. Thank you so much. Have a good one.
Thank you, Megdad. We hope that the first session was like informative and interactive. We know that to some extent, some parts of it are kind of high level, and it might take some time to actually go through the materials and try to see, if some of them make sense and if there are actually issues or you could digest. But just in case there are any issues whatsoever, like I said, we're gonna leave the links so that like anybody can just reach out at any time. And if you have a project that's quite similar or something like that, yeah, you'd have help every step of the way. Thank you to Megdad for that. So the second session will be by Tanin Zerati. I'm going to allow her to introduce herself and, we jump into the second session and the final session. Thank you, guys.
Hi, everyone. My name is Tanin. I'm a master's student at UBCO. I'm hopefully, fingers crossed, I'm going to finish soon and graduate. At the back, we have Leo. I don't know if you see it, but he's going to help us with the background noise, Leo and Peach. So sorry for inconvenience of them like singing or making noise. So I think we would have a small break before starting the second session, if I'm correct, Linda.
Yeah, actually, we're gonna have like a 5 minutes break, just so you guys can, just browse through what we've done so far, see what we've done, see if you can make sense of it. See if you have any questions, send it to the chat. And I think we'll resume, say, 10:22, 23. Yeah, but we'll resume then. Thank you, Tani.
Perfect. So based on the comments that I saw, I'm going to like explain how to use the Google Colab a little bit and also create an account in Hugging Face in case anyone doesn't know about it. If you have any suggestions or need more explanation for anything, you can put a comment I can see and maybe I can like explain those a little bit more.
Okay, we have a hand raised. Kingsley, Tom, you can proceed, please.
Yeah, hello, can you hear me?
Yeah, we can.
Well, I don't like
Hello? We can hear you.
I think you're muted. So,
sorry, I was having some technical issues. Yeah, you want to ask if like some of the links that have been sent on the chat are like having issues navigating them. I want to know if can be forwarded to our email we use for registration.
Oh, yeah,
Maybe
sure.
access this later.
Okay. Okay, sure. We intend to send messages to every participant, just in case some of them don't, we're not able to get some of the links. We would definitely like have like a feedback because we do need feedback after the entire session to see how well we can improve for next sessions. So sure, you get feedback. Yeah,
Yeah, okay, thank you.
thank you.
Okay, then I'd say, are we getting something like a transcript of the session or a recording?
Yeah, sure. I think that would be optional if the participants want like a transcript. Sure, you can get a transcript, but the drive would also contain the recording of this session as well. It contain everything we've done or have or materials so far.
Then I saw a voucher like getting after the session. Is it for everybody or is it a raffle or stuff like that?
Sorry, I did not get that.
Yeah, I said I saw something like a voucher and like an e-gift card. I don't know if for everybody who participated.
Oh yeah, sure. It's for all attendees. We intend to send that via email. If
Okay,
there are any issues whatsoever, sure, we'll communicate that after the workshop. We just want to be able
thank
to take note of participants. Yeah.
you. Just I really appreciate Eva. I can maybe go get a transcript so I could maybe practice what was going through so on my own system also.
Okay. Okay.
Yeah,
Yeah, that's fine. That's fine.
yeah. Thank
Yeah,
you.
I just have one question, Kingsley. So I assume you registered for the workshop, and from there we can easily get your email address because then I'm going to have to take a look
Yeah,
at
yeah,
like
yeah.
all
I
attendees
registered. Yeah,
so that I
yeah,
can, yeah.
registered.
So it's easy to
Yeah,
reach everyone. Yeah. Okay. Thank you.
yeah. Thank you.
Thank you. Okay, I think it's time for the second session. Thank you, Tanin.
okay, so let me start sharing. Okay, so in this part of the training and the workshop, we are going to talk about RAG. I will start by like explaining a little bit about the introduction of the prompt engineering, what is RAG, and then why we're actually having this second session and not fine-tuning would be enough. And then I would encourage you to start coding with me. I will start from the scratch. I hope it's not boring for those people who know how to use it and are more familiar and expert in it. And feel free to interrupt me at any time if you have questions. Linda can help me with the chat. I don't have access to the chat from sharing screen. And okay, let's start. So as Mehmet said, we have the large language models that have billions of parameters, and it's really hard to get those resources needing for training, not even just training, fine-tuning can be really hard and expensive. So people started doing some research and see how can they adjust and update the model so that it's basically for their own data set or for their own task, and it's more adjusted to those parts. So one of the approaches that they used is prompt engineering. In short term, if I want to explain it, is that you play with the input data, the query that you're giving and asking the LLMs for like your questions, if it's a chatbot. What I mean is that you can give more information. So for example, you can say, okay, how's the weather? We are in June or February or August, anything. You will add more information so that you can help the model focus on the similar data set that has seen related to your questions. So it involved people did more research and see how they can actually make it more adjustable and adapted to their data set. And they came up with RAG. So RAG stands for Retrieval-Augmented Generated. So how it works is that it's basically a framework that gives more data and updated data set to the model. If you look at the image on the left side of the slides, so we have LLMs. We can usually just ask them, and as you saw in Mehla's presentation, the response are not usually clean or human usable. So, and also because they're really big models, it's really hard for the trainers to like retrain them or even fine tune them with the newer data. So what they did was that they implemented RAG, which is a framework that stands in the middle, gets your query, and goes and search on the external data set. It can be anything. And then comes and adds the information that it got to the question that you're asking the LLMs. So we have different type of approach, but because of the time limitation here, we just covered fine tuning. Like I explained a little bit about the prompt engineering, and now we are going to go more into RAG, but we have tons of other approaches that you can use. So there are some takeaways and like bad side about each of them. There is no free lunch. So there is always a threshold that you have to have between accuracy or the resource allocation. So for prompt engineering, it's really easy to work. You basically don't touch the core model. You just call it and use it. And it's more intuitive. For the RAG, it's a little bit like more complex than prompt engineering. It's real time, so like you can use like newest data set or information. And it's dynamic, so instead of training the models over and over again, when you have new information, you basically have a smaller data set that the model can access and get more information about it. So it's dynamic. And for the fine tuning, it's because it's doing some few shots learning and fine tuning on the newer data set, it's basically touching a little bit of the model. So it's changing it. It will take a lot of resources, or it depends on the data set and how you're fine tuning and the model that you're using and everything, but it's more accurate. So you have different types of approach. All of them are trying to improve the outputs that the LLMs are generating for you. So based on the resources that you have, the time, the money, like the task, all of that can help you decide which approach you want to continue working with. So we said that fine tuning is more accurate and it's like fits the model more and adapts it more towards your data set and your task. But then why should we use RAG? We can just use the fine tuning. So the thing, as I mentioned in the previous slide, just going through it again, it has access to the dynamic knowledge. It can update like the information, and it's more data set you can add to it. It's more efficient, so you don't need those huge resources, a lot of GPUs to fine tune it. And even for the time, it doesn't take that much time. Hopefully we can go through the codes in this session and you can see how fast this is. And mostly they use it when their task has something to do with updating data set, a lot of information coming in. For example, you have a website or like Wikipedia, and then you instantly want to update your knowledge. So these are the tasks that usually go with RAG and prefer to use RAG than fine tuning. And so the fine tuning, as Mehlet explained, I would just go through it again. It needs more resources. It will adjust the model, adapt it to your data set, and it's basically retraining the model on a specific and smaller data set without like needing to train all of those 7 billion or like 6 billion parameters. So you just like updates a portion of the model. So from here, we are going to start coding. And I don't know if you can see my screen or the slides only. So let's make it double. Meanwhile, if anyone has a question or can't see the slides or any suggestions. Okay, so for this part of the slides, we first wanted to use Magic Carpet, and so I provided this slide, and we also explained in the previous workshop exactly like how they work. But then we, because of some difficulties, we ended up using Google Colab. But anyways, the thing that is really unique and is really useful in this architecture is that a lot of people can have access to the ARC. If you are a UBC student, any of the campus, you can ask your supervisors to give you access to it. And the way it works is that after you log in, you have some schedulers that based on your resources, your model, and the time that you need, and the RAM, GPU, everything, schedules the resources and like divide them between the users, because you are not the only one who's going to use that system. So it can schedule and then start working and training your tasks and your work. So this is really useful. I would suggest that go and read a little bit about it. And if Google Cloud wasn't working for you, you can definitely use this one. So the first step is that we want to go and use a Python code and Python script. So one of the best approaches that you can use and the ways is to just, you can either go Google Cloud directly. I don't know if you can see the second part that is internet or my scripts.
Just a minute, Tanin. We actually have a question. The question is, what are the trade-offs between real-time retrieval, that's RAG, and static knowledge fine-tuning?
Between real-time, RAG, and can you a little bit explain your question? Like, do you want to know the trade-offs like I explained in this slide, or you want to know why can't we use both?
Alex, would you care to clarify? Oh,
Oh,
he said he wants to know why we can use both.
you can use both, but like the best thing, we will continue going at, and at the end of like the slides, I will show you how to use both together. But this is for like people who have really limited resources and can only go with one, or if you just wanted to know the differences and like what would be the pipeline. So like you can, it's the way you want to use them both is to first fine tune them and RAG, not just like RAG and then decides to fine tune them. We will go through it in like at the end of the slides.
Okay, so I think I have somebody saying, is anyone having a problem with data error opening workshop? That's the script. So it depends on how you're accessing it. Are you uploading it to Google Colab? Like you're opening, like since you downloaded the file, you're gonna have to upload it. And what does it show you? Do you have that error? Okay, okay.
And don't worry about the codes. Linda would send them for you, but at the meantime, I will open a new Google Colab and I will share the link with all of you guys so you can copy and paste the codes or like see the updates.
Okay, we still have some other questions.
Yeah, I'll go through the optimization and like fine tuning if you have enough time, but it's like first we are going to start with the RAG itself, because fine-tuning was taught by a method, and then I will go through RAG, and then I will show you the differences between using the base model, just RAG, because you can see the fine-tuning in methods code, and then the pipeline of using fine-tuning plus RAG. So
okay, Cameron, just give me like a minute to try and upload the file, right? And see, yeah, so if there's any other issue, I'll try and fix it and resend to you. Just give me some time. But Tanya will just continue.
sure.
Okay.
So for Google Cloud, basically you just search it in the internet, you go inside it, you create your if you don't have an account or you didn't set it up, because it works on your Google account. So if you haven't set your Google account on your Chrome, it won't work. But anyways, and then you say, I want a new notebook. Another way, if you want to have your data set or save your pre-trained models or like fine-tuned models in the Google Drive, and you want to have access to that, you can just open your Google Drive. As you can see, I have it here. You can put new and then go and open a new Google Colab. And then you can, let me open it from here. Yeah, and let me share it so that you can see the code here. Okay, I will wait a few minutes so that everyone can access the Google Colab. And at the meantime, if you want to access your Google Drive documents and information, you have to mount them. So meaning that connecting your Google Colab to your Google Drive. And so you have different options. There is a code that you can write and then run it, or the easiest way is to just click on this one, which is Mount Drive. It will ask for your permission, and when you go, it will show you all the folders that you have. And then refresh until it connects. Yeah, so this would be the file, and then you can, for example, say, I want to copy the path to it, and then you read it from there. We also have the actual script here that I previously run. I will show you the differences and the samples. You would also have access to this one. But for the purpose of like being hands-on and everyone can follow, we would start coding together. Okay, so hopefully everyone had access to the Google Colab. So basically each of these cells that we are going to use is a Python script. You can write programs. And if you wanna write an information, text, or anything, you can also open a cell that is like text. It can be anything. I workshop. And then you just run it. For running it, you can either click on this one or Control-Shift-Return. So it can work with both. So the first thing we want to do is that we want to use and have access to GPUs. So for that one, you go to the run time, change runtime approach, and then you go to the GPU. The problem probably would be because I used most of the GPUs before this session, it will not let me or stop or get away the GPU, but you shouldn't have that problem for now. And you can easily use it and adjust it based on the if you want CPU more or if you want GPU. Another thing is that you have to make sure while we are going through it, if you got an error that says like restarting runtime or anything, you have to run the code from like the first the code that we are going through. You have to run it from the first cell because you have all this information, it's safe, but as soon as the session is out or you're just cancel your session, close your window, your information is like lost. I will show you what I mean. So for example, if you have downloaded a library when you reopen it, you need to at least like run that cell once again. And another thing you can do is to get like a premium account with Google Colab, and it will give you more time to use each of these sessions. And also you have access to more GPUs. So now that we have changed it to GPU, the first thing is that we want to check if it's on GPU or not. This part I will just paste it so it's faster. And we also need to import all of these libraries that for just being fast, I copy and paste them. So for me, because I've already used the amount that was supposed to give me for today, it's 0, but you would have a different view of it. And if you need to also check your RAM, you can ask for a higher RAM, but for this session, we don't need it. You can increase your RAM as well. So the next part that we have to go is that now we want to install and have access to the models and all the codes that have been implemented. We are not going to implement everything from scratch. So for this one, we need to set up and install some of the stuff, which is easier to install through a terminal. So Google Cloud will not give you a terminal by itself, and you need to directly connect to it. And for that reason, we go to and we use Extern. And then we start downloading the information and the model through that. You can still like use these two signs. The first one is, for example, if you want to install anything, it will give you access to the command line that you can also use instead of Extern, but it's easier for this part of the downloading of the model to use Extern. Otherwise, if you want to just, let's say, install TensorFlow, you would do this. It's easier. Okay. Then I can copy these ones and I will go through it. Okay, so first off, we want to use the Xterm. If you don't know how it will work, if you haven't downloaded it, if you just run it, it will say Xterm not defined. So if you got this error, it means that, and you didn't see like your runtime was canceled or restarted, you probably, if you have already run it and all of a sudden you get this one, it's probably because your runtime has restarted. So you have to run it again. So these ones, as I said, for installing, it's easier to do this one, especially when you don't have it yet. And this tag that you see here is just to say, do it quietly. Instead of printing all of the logs and explaining all of it and make a mess, you can just run it. So it will take a little bit of time. So one really important thing that you might face some errors if you don't like use the same order is that you have to use this order of downloading. So don't download the community first and then itself. So what is LangChain that we are installing and using? It's a framework that helps you to use LLMs and like update them. For example, for RAG, we are using LangChain, and it has a lot of different models, vectors, prompts, agents, a lot of things. You can also explore that and see if it can be related to your research. It's easier to use and implement all of these through LangChain. That's why we're using it. But if you want to have a little bit challenge or you want to try different platforms, we can easily use them as well. Okay, next, now we have Xterm. We want to open it and install our Llama model. The reason we are using Llama here is that it's free. So GPT-4 and 3 are paid, or you have to have the API. So it's a little bit harder for students who are here. They might not have the model already. So we decided to go with Llama. But for your project, you can try all of them if you want. So we have to open the terminal. Okay, this is our terminal that we are going to use to install the llama that we want. We would run this code. I will put it on top if you guys want to copy paste it as well. To install our llama model. So the tags that we are having here, as you can see there, you can use a lot of tags like this one that we use to make it quiet. So while coding in the shell, you can easily add tags and change and adjust them based on where you want to download them, how you want to download. So easily just copy paste it and enter, and you see it's downloading. So what I meant by you would lose the memory after the runtime is restart is that now we are downloading the llama through this approach. So if you close the window, if your runtime restarts, you're out of time, or you use too much resources and you don't have any more, so your runtime would be restarted. So if you want to use llama that I show you the steps, it will show you the error that I show you in the beginning. It will say like the model doesn't exist, or I don't know what you're talking about. So you have to rerun it again. Okay, so it was installed, and now we want to pull it. So you have the information in your server right now, but when you want to call it, you have to pull it. So we use this one. Again, I will put it here in case you guys want to download it, and then you run it. So sometimes you will get the error. If you got it, you just rerun it, and the same code, it will work. I don't know, sometimes Collab makes some fun stuff here, play some games, but it will work. If you have any questions or need me to slow down a little bit or need help, let me know. I can pause or explain more about it.
Okay, Tanin, we actually do have some questions, and I think Megdat can also answer some. So I think the first question we have is, what evaluation metrics are best? Let me see if I can see this very well. Sorry, please. Okay, so it says, what evaluation metrics best compare the effectiveness of prompt tuning, RAG, and fine tuning?
You mean how we can say the difference or compare them?
Yeah,
Or
like how we can compare. Usually for machine learning models, a lot of people look to the normal comparison metrics like F1 score, precision, accuracy, and the rest. For fine tuning and RAG and prompt tuning, what metrics can we use to compare that? Yeah.
So the comparison, it really depends on your task. The way I would suggest it practically is to see some of the papers that have done or used any of these approach. They would usually, because the papers are continuously coming and updating, they will suggest you some new approaches, some like what they have already tried and the results on the specific task. So you can use those if it's like a specific data set. For example, you want to use it on health. And then for you, for example, explainability of the model is really more important, or you want it to be more secured. Based on these ones, there are tons of papers you can go through, and they will explain all of the approaches that they have already used and the results, and then like the drawbacks and takeaways from using those approaches. But there isn't like a variable saying something like accuracy or F1 that can say it goes for all of the topics, all of the data set, that you can compare all of these. It depends. Okay, the question is hallucination. Actually, that's a really good question, Alex. So first, let me explain the hallucination in LLMs. The way it works is one of the challenges that LLMs have is that they can make and generate a meaningful output, but it's not related to what you want. So for example, let me think of an example. You can have a sentence that grammarly or grammatically has meaning and it's correct, but it's not a correct answer to your questions. So let me see if I can find an online example. I don't have any example for it in the back of my mind, but yeah, let me search. So, for example, it says, therefore, it's essential to cross-reference the information provided by LLM. So it's grammatically correct, but it doesn't answer your question. So how does RAG help us with this matter? Because hallucination, you have to first know how it is caused. So sometimes it has a lot of reasons. It has like a lot, it depends again on the data set and the task, but most important ones are if your data set is biased or it's noisy. So you might have that one. And the way RAG helps it is that because it will give you more information, it will try to accommodate and help with the unbiased biased and some of the noisy data set that you have. So this is how it can help you. The LLMs themselves, they've seen a lot of tasks, all of them at once, and like they don't know where to focus, if I want to make it a little bit simple. And so it has a lot of, for example, if I want to make it more obvious or tangible, is that you give features to the machine learning models so that you can get the output. So then it comes the attention that helps you, like which part of those features, which part of your data set can it focus more. It has a little more complex definition, but I just wanted to use it for this question. And then you want to say, hey, model, do you remember me asking you about what was the hallucination? Information provided by LLM. So now you're asking the model to go to your information, go to the data set and read all of these again, like know which part I am focused. If I'm asking the question, for example, page 200 in your textbook or something. So now it goes and it knows which data that it should like focus more and access more. So this is like the way I can explain it a little bit more tangible and easier and not getting into the details and implementation, but this is how it would works. And
okay, so to also add something to that about how RAG handles hallucinations. So generally, pre-trained models rely solely on what it's been trained on. But for RAG, you have both like a retriever and like some sort of, I don't know if to call it a generator. Yeah, so generator and like a retriever and a generator. So if you say what year was FIFA maybe inaugurated or something like that. So pre-trained model rely purely on its knowledge, its pre-trained knowledge, while RAG would then look for factually grounded knowledge. It will try to extract or get or retrieve relevant documents that relate to FIFA and then base whatever response it gives to you on factually grounded data. So it's giving you real-time data, like it's giving you answer based on real-time data, while pre-trained models are usually they rely mostly on what they've been trained on. So that's how I believe that's how RAG handles hallucinations. Something similar to that, or that's the way I understand it.
my email, it's, I think at the end of the slides, we're going to explain it, but I will also share my LinkedIn or all the ways you can contact me. And retraining, it's not like a really accurate word because you're not changing the model. It's just like the update how you're asking the questions through the model. So yeah, but that's correct, the general of it. Okay, so let me research. reshare the screen. Okay, so hopefully you were able to download it and have a correct and like pull the model correctly. So the next part is that we want to import some libraries and some of the models and information that we want to use. The first thing is that we want the model. So you come and I can code or I can copy paste because I think we don't have a lot of time. I will copy paste this part. And then you want to call it and use the model. So we are here using Llama 3. Again, I said it's free and easier to use, but you can use other models as well. So you call the model and then give the parameter, which is hopefully I didn't have okay. Let me pull it again. It might have been. Okay. Yeah, this is what will happen if you use all of your resources. So I have to get access, pull it again. This is, oops. Okay. Yeah, probably just a typo. Okay, so now we have it. And for testing it, we can just ask a question and see how it works. For asking a question or like for next steps, if you want to have a chatbot, you don't want to like adjust or do anything, you can just use the invoke function. So you can say response equal to LLMs. You have different functions that you can use from it, but for now, we're using this one. Evoke queries, let's say. So we have an answer here, and then I will pause a little bit, like 1 minute, so that I'm sure everyone is following. Okay, now we want to start integrating the RAG on the model, the base model that we have now, and see how it will affect and change our results. So again, first we have to install it. So pip, which is the way that we usually install libraries, it's with Python. So if you want to install Python libraries, you can use that. LangChain, I explained about it. And this one is developed by Facebook AI Research. It's helpful for clustering or like optimizing large data sets. So that's why we're using it. And then sentence transformers, this one, it provides us with a pre-trained model for generating vector part of it and like embedding it. So now we want to get all the libraries that we want to use, which is all of these ones. So next, after importing all of the libraries and everything, this is, before I forget, this is how it will show you if you don't use the tag dash QQ, that's what the silence part means. Okay. The next part, again, like initial your model. So if you have already, oh, sorry about this. Leo is on the way. So if you have already initialed it, you don't need to rerun this code again. But if you haven't, you need to call your model again. Okay, so this one is the script that I've already run. I will put it in the other one as well. While it's running, I will just explain over it. So you imported the libraries that you want to use. You called your model, and the next step is to use embedding. Embedding, for those of you that don't know like the concept of it, again, I would just give an overview about it. Is that when you're giving some text to your model, it cannot understand those texts and the position of the words and all of the like grammar and everything. So you need to embed it, meaning that you will choose like a vector of numbers that represent a specific, for example, token or the word, a word or anything in your sentence. So we need to embed our information. And then the most important part of the RAG is the document that you're going to give it. Document is that extra data set, extra information that you're giving it. So it can be here, I made a really simple information about it. And the reason I'm trying to give some wrong information is because I want you to see how this information can affect your model. Yes, if you see this one, you have to rerun a lot of stuff. Sorry for that. I have to rerun it. Yeah. Oh, I was in the other section. Sorry, missed it. Anyways, I wanted to show you how it affects the response of the model, and based on the data set that it has already seen, and the new information that you're giving it, how it will handle the situation. So we will again copy this one, bring it here. Okay, so this is basically you're telling that read from this document, and based on the embedding that you provided for from the already implemented, you don't need to implement those things, you just call them. And you call the retrieval QA, which is a question answer RAG that you can use. So you have to pass your LLMs, and you have chain type, meaning that how do you want to give your information to the model? Stuff meaning that you want to give all of it at once and not separating it. You have, you can do memorization, summarization that will shorten your information, or you have different types. So here we just want to give all of it at once. I restarted this one. Okay, sorry about that. My Google Cloud probably crashed. Okay, I can explain on the previous results that I have. So then now that we have fed our extra data and information to it, now we want to ask some questions and see how it will affect it. So I asked, what is the capital of BC? Who is the president of US Canada right now? And how is the weather in BC? So if you see here, I have some wrong information that I have provided and some information that do not match. So here I'm saying the BC's weather is warm. This is, I say it's sunny and cold. Here is cold, here is warm. So based on the output, as you can see, so here it says that you basically didn't give a correct information to me. But as you can see, it has it. It has seen the data that I've passed up to it. And it says, okay, it's wrong and it's not Ontario, which is another province. And it will try to like give a correct information, but based on all of those information that it has seen already, because the number of times that it has seen it is also important. So the one thing is that it says, according to the President of US, according to the context, the document that I've provided, it's Biden. So it's not updated. It means that this model was not trained when, for example, Donald Trump became the president again. So it only focused on the information that you give it. And then how is the weather in BC? So here is the interesting part that you see it cannot decide because it has seen this data based on what you gave it, and you are giving two different answers. So this is how like RAG can be used, and the data is really important and affects the model that has billions of parameters. It has seen tons of data and information, but still this is how the RAG will affect your model. Okay, so the type of documents that you can give it, it can be structured text like papers, website, everything. Unstructured are the ones that are not clear, like the information is everywhere. Structured text is text, website, anything that is text or numbers, or this will work. Semi-structures are like they have some tags, like for example, HTML websites or some specific website that they have, or like JSON files or this kind of files that are structured in some parts, but they also have tags and extra information. And multimedia content, audio, picture, anything related to that. So you can pass everything based on the task you're doing. Okay, the next part is, let me go here. This is a duplication. Okay, so we have implemented the QA system. And here again is the explanation of this stuff and other things. The next task that we are going to work with is the summarization that you've seen ChatGPT and all of these generative AIs do it. So I also explain how it works. So you remember the chain type that I mentioned in the previous one? This one makes it to map and try to reduce the size of the queries that it's giving the model. So this is not a good example that I put here for the text because it's short, it's not multiple paragraphs or a lot of information, but you can still see how it works. So again, you use the available functions, you don't need to implement it, and invoke, which is like calling and saying to come and do the task for me. And then you see it's trying to smaller the information a little bit, but because the string is small itself, you don't see that much difference. So what it means is that if you give more information, more text and more lines, paragraphs, it will make it even shorter. It will map it. So that's how it works. So till here, does anyone have a question or stuck on implementing or running it? Let me open the chats here. The next part, I want to show you how to use fine-tuning and RAG and their different information. You're welcome. Yeah, sure. Because the collab crashed, we don't need to rerun all of it. So yeah, the next part I want to talk about how to use them both and their differences. We can like try them with a sample, but till then I will like give a 5 minutes if anyone wants to go through the code or you want to run it, or like me, you had a crash here, you want to rerun from the beginning and see the output, try some other stuff. And if you have any problem, you can share your screen or ask questions or any way that you think. Sorry, we have Leo interrupting this session. Okay. Okay, so everything good? Any questions? Or should we continue? And one more thing, I'm trying to like explain it from scratch. If it's too fast or you know it and you need more resources to study it or go through it deeply or in details, let me know. I can share you the references or the papers that you can read about a specific area. Okay, perfect. So the next step is to, as always, install all of the information that we have, because I've already installed it, I commented out, but if you haven't, you have to install it again. And then here we get to how to use and connect to Hugging Face. So basically the way that we are using the models, or we are calling it, or the way that method showed, is the Hugging Face. So in order to connect to it, you can use this code, which is logging in. And, oh, I think you cannot see my screen. I think now you can. Okay, so let's go and see Hugging Face. So you have access to a lot of information, data set, models, everything. You can just search around it, choose it, and they will give you some samples of how to use it. For this part of the workshop, when you run this code, it will give you that you need to have authentication and permission to use it. So previously, I have created a token that it will ask you to upload here. Like when you run it, it will open a section here, ask for your token. So then here you have to create a token if you don't have it. You give it a name, and then based on the information and the type of the model that you want and the task you want to do it, you choose your permission that they would have, your token would have. And so after that, when you create the token, choose your type, oops, it will generate you a token. And then you just copy and paste it here and enter, and then you have access. You have currently have an active token, which was at that time. Okay, 2 minutes. So if you wanna create a token, you can. For this part, you can just give access to reading or just writing on the memory. That's you don't need a lot of details. Okay, so you choose the model that you want to use, and then the tokenizer, which is the same as the model name, and then you call the model like the way you've already seen it. And this code, I'm just trying to push my model to use GPU. That's like the only purpose of this one. And after you run it, here my GPU again crashed because I used it too many times. But let me see if I can rerun it. So as it's running, hopefully we can see the differences here. I gave a prompt to it. You can make it shorter or you can make it long as you want. This is like the information that you want to ask it. So then I asked them, okay, your base model that is the basic, not fine-tuned, nothing like extra. I will ask it and get the output, ask it to like generate something. And then in the next one, oh, sorry, he was being furious. Okay. So the next one here, I'm trying to implement the same documents, the prompt that I wanted to give the model, the base model. And I want to see the comparison using RAG. So I have to give a little bit more information about it. And then in the last part, I'm trying to use a fine-tuned model. So Hugging Face also have some models that have had the base model and then fine-tuned on a specific data set, and you can use it. So because the task that I was using was not really complex or needed extra information, I just went with the sample fine-tuned ones. So then you do the fine tuning as Mehrdad has explained to you previously, and then you do the retriever part, which is for the RAG, and then you make it a pipeline. Then you can see the output, ask a question. We use this one in the previous parts, and then you can see the difference. So I have to see if, yeah, it might take a little bit time because currently I don't have any GPUs left on my Google Colab, so it will take a little bit of time. But in the meanwhile, if you have any questions or anything, feel free to ask if you wanted to, if you have an error or trouble doing any of these codes, just let me know. So now we talked about what are the good things about RAG, but RAG is also not perfect. So they all have limitation and some threshold that you have to be careful about it. So although you're giving extra information through RAG to your model, but what if it brings back all those irrelative and inaccurate information in your data set? So for example, even if your data set that you're giving to your model, if it's biased, if it's nosy, or if it has any other trouble, or even the resources that you're giving is good, but then your model is not 100% accuracy. So it might bring back irrelative information, especially that RAG has a way of giving the documents to the model based on ranking the information. So sometimes the more higher ranked information that comes out, it's less relative to the ones that you had before. And it also really depends on your large language model that you're using. So it cannot be perfect. So sometimes you will see inaccuracy. It doesn't mean that if you use RAG, you won't have anything or your hallucination is completely okay or fine. So you still would get those limitations as well. Computational cost is less than fine-tuning, but it's still, you see, needs GPU and time because you have the model, although you're not training it or fine-tuning it, you are still having that part of the model and then your retrieval side of the model that still needs resources and time. And then the final thing is a reliable data set. As I said, it's hard to nowadays with this AI and everything. The most important thing is data set. Not we have access to tons of data set or information. Sometimes they don't have labels, or it can be really hard to access data sets. Sometimes because of the security issues, you won't have access to them. Sometimes there isn't any data set related to it. So. And you need a lot of information for even fine tuning. It's not like you can go with like zero shot or a few shot learning, but still that if you want to use information, you cannot use the 5 sentence that I gave here as a sample. You need more information. That's what I mean by a lot more information. And yeah, so we have a lot of resources you can have access to. A lot of papers on the internet. I provided the resources that here are easier to follow, or they have more samples in case you want to go through another resources to reading all of the details. Or if you want, you can shoot me an email. I can send you tons of papers related to them. And I think my collab again crashed. Yes, so I don't see any hope here for running this part. I encourage you to run it. If you had bugs or errors or anything, just let me know. I can help you with the implementation. So any questions? Oh, I'm seeing some. No, thank you so much. Happy you liked it. I hope it was clear. I tried to cover both basics and a little bit more information included in the slides. Or I hope you liked it and you learned a little bit of how using it, because personally, I think there are tons of information on the internet, but when you run the same code, you sometimes get a lot of errors. So it's a little bit hard to find a good resource there. And the last thing I think Linda would send the information to you guys, but if in case you want my LinkedIn, this is the QR code. You can send me information, or my email is basically my first name dot my last name at ubc.ca. You can always shoot me an email if you want to have a short meeting or discuss anything. I love research and technical communication and conversation, so just let me know. And that's it. Thank you so much.
I think we have a question. How does incomplete or outdated indexed data affect RAG responses?
So one thing is that if your data has been seen by the model, so like, for example, if I remember correctly, the first time that ChatGPT came, the GPT-3 was only trained until the information on 2021. So if you're not providing the newer data set or newer information, the model has already seen it. So if you're asking about the dynamic and update information, there won't be any point in it except like pushing the model to like emphasize on that part more. But if you mean by, for example, then fine-tuning by 2024 and then using RAG, your question was outdated. So let's say, for example, your model was trained by until 2023 and then fine-tuned on a health data set, and now you want to ask some question about COVID. And you have a incomplete data set. So if your model hasn't seen those information and you're not providing extra information, basically there won't be that much an effect. So let's say for the time that COVID didn't exist, and then you ask the model about COVID, it will generate something for you because the way it works is that it will predict the next word based on the topics that you have already given it. But if it hasn't seen it at all, it will just generate something for you. I don't know if that was your question, if you want to clarify or like give an example, but
Okay, I think we have another question. How does RAG handle ambiguous or multifaceted queries?
Like the sample that I showed you that, for example, I gave let me find that and share it again. So like here that I said the weather is warm and then it's cold. As you can see, again, it really depends. Oh, you're not seeing it. It really depends on how you're giving the information. Even the writing of the prompt is really important. That's why we have a separate field called prompt engineering. All of these details are really important, but this is a sample. You see that it will say it's not clearly indicated based on the context that you're giving me. So it first goes and look into your context. So here, if you remember, the new data set that you're giving, it's in between. So it's in the first step that it will go through and get the information is from your context. Being sunny and warm. So you are seeing that it's having a little bit difficulty here to say which is it. And then it will go back to the information that it has. So that's why here in the limitation that I said, if it goes and gets the irrelative, is it here? Yeah, irrelative information, or if you ask for the ranked one, it will bring the irrelative ones or the confusing ones. This is going to what happened and how it will look like. Because it cannot use the information that you're giving it. So first of all, it would be really hard for it. What we can do is that I can ask about the weather here. Yeah, I've already asked here. Yeah. So at first I asked about this one. And then I'm asking about let me ask the weather so that it's more obvious. Oh, I didn't need to run that one. It will, basically what I want to show you is that it will connect to the information that it has and it will generate based on the information that it already has and seen. So if you don't confuse it, it will still go and read it from the ones that it has seen. But if you confuse it, you see, because the RAG part is the first step, it will go through RAG and then your LLMs. So it will really confuse the model and it cannot decide which one it should generate. Okay. I have to call it again.
So for Kimeto, what's like to add to what Tanin is saying, about ambiguity or multifaceted queries, there was a part of the workshop where she talked about ranking. So it's just going to look for the most contextually related information that it already has to answer the ambiguous query, or it's just going to add it's just going to do some form of retrieval mechanisms where it just adds synonyms just to make sense of the query. But the downside to that is there's every possibility what you might be getting might actually be inaccurate, right? So you need to be very, very clear with your query. Yeah, but that's how I think that's how RAG handles it based on what she has said so far. We have another question, how I handle specific prompts. Okay, so I'm not too clear if the person could just clarify. Do you mean how does RAG handle specific prompts? Maybe that's the question. I'm not too sure.
So
And then we have I'm so sorry. Yeah, you can answer that.
The prompts, if you mean like the questions that you're sending to it or the documents that you have already asked for it. I'm not sure about your question, but if you just want to say how you can improve the way you're asking the LLMs, the really quick answer, it's again, a lot of research has been done on it and there is not like a perfect answer. But the really basic one is that if you provide more information in your prompt or questions that you're asking, it will give you a better and more accurate result. Not always, but this is the basic idea.
So we have another question. Can the model be used in normal engineering? I do not know what you mean by normal engineering. Maybe Tani can make sense of it. Can the model be used in normal engineering?
If you want to say, for example, let me think of a sample of engineering. So let's say your model wants to engineering, computer science, computer engineering can be also included. So let's say you want to, for example, train your model on the coding part or helps you to code better on a specific topic. For example, let's say gaming. So you have the most challenging part based on my experience is to prepare the data set for the model because calling the model is easy, but the structure of the data set should be in a way that it's easy for the model to learn or fine tune over it. So if that's your question, can be used, yes, you can use it basically on any data set that you want, but the challenge would be how to prepare it. If it's code, if it's image, all of those would go to the part of the pre-processing of your data set and preparing it. That is challenging. But if you again want to know more and see if they all already some work's done, you can here go to data set and then choose the data set that is most closely to you and then see if it will be helpful. Okay. So here you see it will generate a good answer based on the information. So for the person who asks like, how can you improve your prompt? You can ask like specifically for Spring, and then it will give you even more and more information about it because it's focusing on your question, which is the Spring. But as you can see, it was able to generate a good answer. But when we try to like make it confused with the document that we are giving, it couldn't even say the correct answer. It would say, I don't know, based on the context that you're providing. I hope the sample was good. If you want, I can try any other information, or you guys can also try it and run the code. Any other questions?
So somebody says, I am looking for data set of plastic for recognition. Okay, so I'm a little bit confused. Do you mean a data set that is just maybe images of plastics? Do you mean that? If that's what you mean, I think we did a if it's plastics in terms of bottles or things like that. So we did a course that can recognize plastics. Okay, so I think we did a course machine learning. Um, so we had to gather data for plastic bottles. I think we still have the data set. If you'd want, we can send that to you, or you can just check on. I think there's Cargo. You can check on UCI. You can also check. I don't know if Hugging Face would have any data sets. Um, like that has plastics or something like that. Or, but if you, I'm just trying to frame your question the way I understand it. But if you could clarify, maybe it's the model for plastic recognition you mean, you can still let us know. Yeah. So
And
there's another question. Oh, yeah.
sorry for answering the previous one. If you're asking if every time you want to ask the question, no, you just give your documents information once, you call this function and then you get it. The next time you only ask, unless you are updating your data set and you want to give more information to it. But other than that, you just give it once. Here I can add as many questions as I want. So if that was also your question, that's it.
Okay. So he said, I would love that. It's to just train my model based on the blockchain of plastics. Okay, so you know what? So that would be like very clear. If you could like email us at edichampions@gmail.com, and then we can maybe go along with you to see exactly what you're asking. So then maybe it will be better clear to us by then. Um, I think there's one question. Does RAG require frequent updates to its retrieval database?
So I tried to answer that through the documents that I said. So every time you ask a question, it's basically going and coming. It's like the LLMs and everything. But again, you only need to pass your documents once. Every time you want to ask a question, you don't need to call this function over and over and then pass your documents to it.
We also have another one. How can RAG be fine-tuned for specific industries like healthcare or law?
Mhm. So, a little bit technical things is that RAG will not be fine-tuned, if I understand your question. So fine-tuning is something, RAG is something else. If you mean that, how can you do a fine-tuning and then RAG? So for example, you're using Llama, and then you have a data set of all the law cases or information based on the rules and laws and everything. And you fine tune your model on those data set. And now something new happened. For example, you have a case and you have extra information. And for example, an update for, I'm not like a expert in law. So if I put some wrong information about it, just an example. So if a law was updated or extra information came, so now you can use RAG and just fit it into your model instead of adding it to your data set and fine tuning it again. So this is how you can use it. But because sometimes your information, let's say you have a data set, a lot of data set information you're fine tuning your model on, and now another update came that is smaller, but if you add it to your fine-tuned data set, again, it might take a long time. So it's not worth your time and resources to fine-tune the whole thing again. So you just use RAG.
I think I'm muted. Okay, so we have, what are the key performance for fine-tuning RAG? More like the KPIs.
So what do you mean by performance? I don't understand the question. So like performance, you mean
I
based?
think it's still the you know, the way they asked about evaluation metrics earlier, like maybe a way to measure, yeah. So I think it should be like a way to measure the effectiveness of RAG, the way we measure the effectiveness or how well a model performs. So
Mhm.
something like that. I think it should be something like that.
Yeah, so it's again depends on your topic that you're researching. So if you mean like does it have a variable called like accuracy that you can say or perform? It depends if it's classification task of like basic information about machine learning, if it's generating a code or is it generating some literature information. So we have some sequence to sequence variables that you can use, but it's really specific to the task that you're using. And the reason I'm saying it, for example, let's go to a simpler example. You have a data set, which is a classification and it's binary. And your model is predicting all of your test data set as 0. And for example, let's say your data set is unbiased and 70% of your data set is 0. So when you want to use accuracy, it will give you 70%, or if worse, if it's 90% zeros, then it will predict as 90%. But accuracy here is not a good way to saying it because it's not predicting correctly. It's just predicting all of them as zeros. So then you use, for example, F1. So you have different metrics. So this is what I mean by depending on your task is really important that what thing you're using, what variable you're using.
Yeah. Also, I think for that, so because RAG is actually divided into like retrieval, then there's generation, you might actually have different ways of quantifying it. Do you want to measure how effective it is at retrieving maybe relevant and useful documents, or do you want to look at how effective it is at generating, or maybe just the overall system performance? But if you're looking at, say, retrieval, you might want to look at like the recall, you might want to look at precision, and there are other evaluation metrics. I think like I think it's normalized discounted something gain. I don't kind of remember the complete word, but there are several evaluation metrics. So it depends on that's why Tanya keeps saying that it depends on the specific task that you're doing and which one actually measures or provides effectiveness for your specific task. So you can always check online. There's even something called retrieval like latency, measuring how fast RAG is retrieving your useful or contextual documents. So there are several ways. Yeah. So we have another question. How does RAG handle multi-language retrieval and generation?
So you
So
mean how can you send it as an input or like can it handle? Yes, it can because it can get the documents that you can pass it to can be media, pictures, text, numbers. It can handle it, but preparing your data set is like the whole new field of pre-processing it for like the multilingual, multi-language, or sorry, I
yeah,
mixed it
it's
with
multi-language.
so like for example, translation, yes, it has like this here that we used retrieval QA, if you remember, or I did summarization. There is one that is for translation. So you can just call it the way you used the QA one.
Okay. So can I know the data sets or metrics for fine-tuning RAG?
For RAG, it's not like we can say there is a specific data set. For example, if you don't work on health or law, you cannot use RAG. You can use it on any data set, but if you want to practice on one, you can use so like the Hugging Face has tons of data set. You can get information of it, or you can just browse the internet, get some information of it, and then pass it and see how it affects that.
Okay, I think we still have something similar. Like, what are the data sets for fine-tuning RAG?
Hmm. So does it mean that I am not understanding the question? So do you want to clarify? Is it the same as What are the data set? There are tons of data set, like a lot in any field that you want to work on. Some people don't provide their data set through their papers. You can email them and ask them for it. But there is not any specific field that you can say, oh, if you don't go and use this one, it cannot happen. So you would see a tons of papers and research that use RAG and fine-tuning on a new field, for example, oil and gas, or recently it's been law, or yes, health is one of the famous one, but for example, for coding. So you can use it and it can be a new paper for you and the field that you want to work to use the existing one on a new field or area that no one has already explored. So there is no limit for it. As long as you can prepare your data set, you have the information and a long list of data analysis approaches for handling it, you're good to use this.
So it can be like it can be in any domain.
Yes.
Language. Yeah, so it can be in any domain. It's still specific. Just depends on the task that you're trying to perform. Do we have more questions? Do we? Tani, will there be anything else?
No, that's good for me.
Okay. So thank you, everyone. We've actually come to the end of the workshop. I just have like a few announcements before we leave. First, we actually want to thank everybody for attending this workshop. I want to believe it was really helpful, and because of that, we'll be putting a questionnaire. We're sending a questionnaire your way, to help us better improve. And if there are things you feel should be added, for maybe other sessions, or however you feel we can improve. And how you found the sessions, it's going to help us as well. Also, one of the reasons why we created stuff like this was so that we could bridge like a digital divide with students here at the University of British Columbia, Okanagan. And when we first came, we did not know about a lot of tools that could really help us with our projects, with our thesis. And when we became acquainted with the Digital Research Alliance of Canada, we became acquainted with so many resources that could really hasten our projects, and we no longer had to rely on, some manual methods. So it's really, we had one session last year to introduce people to the DRI tools. And though the Digital Research Alliance of Canada tools is actually applicable just in Canada, we also believe that there are other maybe replications in other countries like the US, Ukraine, and other countries. We feel there are structures like that are available. And the way you access HPC clusters and things like that, it's I want to believe the method is similar. So we hope that we've been able to provide you with something educative and informative. We know that in some ways it can be high level, especially if you're just new to LLMs, but we want to believe that if you take your time, you could understand some things. And for that, we're going to upload materials for the workshop on the drive. We'd also send a link, right? We'll send a link so that if you have questions, or you're working on a project and you keep running into problems, somebody can help you, take a look. And we also have like a DRI Ask space. We'll send that link as well in the email. We also acknowledge Dr. Ifoma Adaji, who's like our host, and she is the director of the Persuasive and Social Computing Lab. We acknowledge Dr. Fahad's lab, from which Megdat came. We also acknowledge Dr. Eve's lab, from which Tanin came. We're going to send the links to all these labs so that you can see some of the works that is happening in these labs. And we just want to say thank you for attending the session. We'll be sending out e-gift cards to participants via email. And we just want to say that if you don't get your e-gift card by Wednesday, you can always reach out to EDIA and just let us know, right? Just let us know. Somebody is asking how they're gonna be able to access like future sessions. Because we have the emails, we can always send messages if we're going to have like future sessions. So please, if there's any issues whatsoever, please let us know. If you have issues with your projects as well, because this is a learning grant for all of us as well. And we want to know what you're doing as well with data, with AI, with large language models. And we're really grateful that you could actually make our time to be here. Thank you, guys. We'll send emails as well. Thank you very much. Bye. See you in future sessions, hopefully. Bye.
Thank you, everyone. Bye.